So today's session we will be discussing about queues. What is a queue? What are different operations we perform on queue? So when we go with queues, queue is a non-primitive linear data structure where the elements are inserted from rear end and elements are deleted from front end. So when you have a queue as like our data structures like stacks, this is also a linear data structure where we will do insertion and deletion of elements. But when we compare with the stacks where we will be inserting and deleting elements in the only one end, that is known as a top end. But here it is not like that. We will be inserting an elements from rear end. That end is known as rear end and deleting the elements from one more end, that is known as front end. Okay, when you come with this example, look at this example, the queues are represented in the memory in this way. So when you take the queue, stack will be represented like this, but the queues will be represented in this way. Whenever we take this, we always see to that we will be inserting at rear end and we will be deleting at front end. So rear end is nothing but insertion end, front end is nothing but deleting end. Okay, so this is the very important thing we have to note down in stack. This is we insert from one end and delete from the other end. The insertion end is known as rear end, the deletion end is known as front end. This is the definition of queue. And when we go with the stack, we already know when we insert an element, we will be inserting element like this and we will be deleting the first element. The last element which you have inserted will be the first, that is last in first out. But what is a queue? Look here, queue is called as a first in first out. Why? How this is known as first in first out? Look here, there is one simple example. So when you're standing in a library, set of students will be there. You will be standing in a queue. So this will be the first person. This will be the second person to come and stand in a queue, and these will be the n number of persons will be there. So when you are doing certain task, you will complete the task first, and you will come out of that queue. Okay, so that is first in. You will be the first person to stand, and you will be the first person to come out. That is what a queue. That is how queue works. That is first person comes, he finishes his work, and he will go out. That is known as first in, first out. So queue is called as first in, first out manner. In operations which are performed in a queue are in first in, first out manner. The first item which you will insert will be the first item to be removed from the queue. Okay, so it is an ordered group of homogeneous items. As I told you, it has two ends. Items are added in one end, it is deleted from the front end, and especially it follows first in, first out property. This is known as queue. So when you come with the pictorial representation of a queue, the pictorial, look here, this is the pictorial representation, and indexing, this is like an array itself. The indexing start from 0, 1, 2, 3. Here I am taking n as 5 number of elements. So I'm taking it as 4. And how the insertion will start? I will take this as a rear end. So now the insertion will be starting at this end. And this is known as a front end. I can delete the elements from this front end. This is just a pictorial representation. We'll be seeing the basic operations when we go with the queues. So always see to that front end we will be deleting the item, rear end we will be inserting the item. Okay, but beginning whenever we insert a front end and we insert at a rear end and we delete at a front end, always they both will be somewhere in the same place. That way either you can take it as -1 or you can take front in 0 position or rear in -1 position. So you can insert the values. So this is how we will insert the values in a queue. So queue is a nonlinear data structure where we are performing the operations of insertion of item in one end and deletion in another end. And this is also very important. We tell queue it as first in, first out property. That is, first person will come into the queue. That will be the first person will be deleted from the queue. This is what some important implementations we will be seeing. So when you take a queue, queue can be represented in either array base or even you can represent them as linked list base. This is linked list representation. This is array representation. As I told you, there will be two ends, front end and rear end. Look here, indexing will be 0, 1, 2, 3, 4. I have inserted the items. So for insertion, front will always be here itself. Till you delete the item, the front will never decrement. So since the rare was here, for example, I'll take rare, it has -1. I have incremented rare by 1. I have inserted 2. Again, I have incremented rare. I have inserted. I have incremented rare. I have inserted 5. Again, I will increment rare. I will insert some other element. For example, 4. So rare will come here. So rare will be here. This is how we represent in form of array. This is the representation of queues in an array. In our data structure subjects, we have queues with the representation of arrays. And you can even represent with the help of linked list also, where in linked list we will be using the pointers, that is information field and address field. Address field will note it will point to the address of the next node. So here there will be front end and here there will be rear end. This is what the representation of queues in our arrays and linked list. So when we go with queues, operations possible on queues. So insertion operation, deletion operation and display operation. And this insertion is also known as enqueue. Deletion is known as dequeue. Display is usually it's the display element. So three operations are there: enqueuing, dequeuing and display the operations, display the elements of the queue. And when you come with the types of queues, we have ordinary queue, linear queue, circular queue and doubly ended queue. So these different types of queues are there, and all these three important operations will be performed on all these different types of queues. Ordinary queue is just a regular queue, and there is one more queue known as linear queue, a circular queue which will be represented in form of circle, and doubly ended queue will be having two different, that is two rear ends and two front ends will be there in a doubly ended queue. So when we have different operations, we will go with the particularly ordinary queue and we will see some simple example, that is simple operations like insertion, deletion and display on the ordinary queue with some snippets of algorithms. Okay. So ordinary queue is a non-linear data. It's a linear data structure where elements are inserted from rear end and elements are deleted from the front end. Since the first item inserted is the item, so this is known as FIFO. Same as a normal general definition of a queue that is implemented. That's the same definition for ordinary queue also. So what are the different operations you can perform? You can insert an item into the queue, you can delete an item from the queue, and you can display the contents of the queue. So these are the three important operations that we have in the queues, and we will see these operations one by one now. So now insertion at rear end. I have taken some snippets from the textbook. Okay, insert at rear end. Why? Because always insertion should be done at the rear end. So we are taking this as rear end example. So now, for example, I have taken a array like this. So now look here, as I told, the front will be, you can take front as 0 or you can take it as -1. Now in our snippet, we will be taking front as 0 and rear equals to -1. Rear will be in -1 indexing. Now we have to check whether, first we have to check whether the queue is empty or not. Then only we can insert the elements into queue. As we did in our array stacks, the first thing is, first we have to see whether the stack is empty or not. Then once the stack is empty, we'll start on inserting the elements into the stack. Here also same thing, we have to first see whether the queue is empty. So now since rear is pointing to -1, the condition rear equals to -1, meaning is that the queue is empty. If rear becomes size -1, the queue is full. Those are the two important conditions we have to see. Now rear equals to -1. Since rear is at -1, the queue is empty. This is an empty queue. So now we can start inserting the item. How do we insert the item? Always see to that only from the rear end we have to insert the item. Now to insert the item into this location, what I have to do, I have to increment rear by 1. That is rear equals to now rear plus 1. That is -1 plus 1. So that is equals to 0. Like this, first we have to increment the value of rear. Now rear is incremented, rear will point here and I will insert a value 1. Now again I have to insert, now rear is here. I have to insert one more value. Now increment the rear to here. So insert one more value. So again I need to increment the rear by 1. Again increment the rear by 1. Again, increment the rear by 1. Now, finally, I have inserted all the elements into the queue. Now, again, you increment the rear by 1. It is not possible to increment the rear by 1. Why? Because the value of n, for example, now I have taken n is equals to 5. So, the indexing, it is out of indexing. So, at this point where rear is equals to size minus 1, the thing is your queue is full. So once the queue is full, you cannot insert a new item into the queue. Okay, this is what the simple logic to insert at rear end. So this is what a simple snippet. Now look here, front is always 0 because front is at 0th position only. I'm not incrementing any front value because if I keep on incrementing front, I have to delete. Now I'm just inserting. So I have inserted 10, 20, 30, 40. Now rear is 3 and rear is here in this example. Rear is equals to 4. Now queue is full. So since the queue is full, I have to stop here itself and I have to see that the elements are all inserted into the queue. Okay. So to do that, very important thing, this is the very important thing we have to note down to insert an element. First is rear equals to rear plus 1, then queue of rear. Since it is an array, I am taking it as array name as queue and I am taking it as a rear. Okay. So the, like whatever the arrays we take, a of 0, a of 1, a of 2, like that. But here I am taking it as a of rear, sorry, queue of rear. So then I insert the item. First, you need to increment the rear value, then insert. Like our stacks, what we do first, increment the top value by 1 and then insert the element into the stack. Here also same thing, increment the rear by 1, then insert the item. So this is how we insert an item into a queue. Then what do we have to do after inserting an item? We have to again increment rear by 1. So that snippet is given here in the algorithm. So now look here, first very important thing, I have to check whether it is overflow, that is it is empty or it is full. This is very first important condition we have to see. Now rear is equals to queue minus 1. The condition is overflow, that is you are not able to insert any items into the stack, sorry, queue. Queue is full. Now what is the thing I have to do? My queue should be empty. Either you can use rear equals to queue minus 1 or even you can use rear equals to minus 1 condition. Even that is also okay here. You can use both the conditions. Okay, if r equals to minus 1, the queue is empty. Okay, now why we see this overflow condition? Because this is the thing when if it is overflow, I cannot insert any item into the stack. Only for that purpose we will be using this. So queue size minus 1, that is as I told you, it will be all, that is like this. Or now rear equals, now for example n is equals, or queue size is equals to 5 in this. Okay, what is the rear now? Rear equals to 5 minus 1, that is 4. So now queue size is queue size minus 1, rear equals to queue size minus 1, that is the condition is queue is full, that is overflow. Now if it is overflow, you cannot do anything. If this condition is true, you have to come out. So if this condition is false, now for example, I'll take an empty queue. Like this, I'll take an empty queue. For example, now r equals to minus 1, it is not equals to size minus 1. So at that time, what happens? This condition fails and you can come to this condition, increment the rear by 1 and keep on inserting the item into the stack, sorry, into the queue until you reach this condition. If once you reach this condition, it will show you that queue is overflow and you cannot insert a new item into the stack. This is how we insert an element into the queue. Sorry, not stack, it's queue. Now we will see how to, now we have inserted an item into the queue. Now queue is full. Now we will see how to delete an element from the queue. So this is what a simple snippet I have here. How to delete an item from a queue. As I told, when you want to delete an item, your queue must be full or certain items should be there in the queue. That is, front will be 0, rear will be greater than front. This is very important. Rear will be greater than front. Somewhere rear will be greater than front. That is meaning that certain items are there in a queue. Now, front is pointing to 0th location. Rear is pointing to 4th location. Now I need to delete an item from the front end. You should not delete an item from rear end. This is very important. We need to delete an item only from the front end. Now what happens? Now already front is in 0. If you want, you can start a snippet from front equals to minus 1, increment front by 1, then delete. Now I have already taken front equals to 0. So now I will delete 10. Now after deleting, what you have to do? You have to increment front by 1. Front is now incremented. Now you delete one more item, bring friend here. Okay, now delete this item, again increment friend. Delete this item, increment friend. So now look here in this point where front and rear are pointing to the same position. Front and rear are pointing to the same position. Even still one item is there. Now again delete this item also and increment the rear by 1. So now once you increment the front by 1. Again now we increment the front by 1. This will be the stopping condition where you can check that now front is greater than rear. When front is becoming greater than rear, it shows that your queue is empty. You cannot delete any item from the queue. Okay, this is where the stopping condition of deletion takes place. Okay, now look here. Very important thing, like in our stacks, what we do first, we delete an item, then decrement top by 1. Here also same thing, we will delete an item, that is item equals to queue of front plus plus. Delete an item, then increment front. Like this we have to do with the queues. So for that we have a snippet of algorithm. Look here. First, as I told you, front is greater than rear. Once you reach a condition where front is greater than rear, all the elements in a queue are removed from the list. That is very important thing. That condition we will be checking. That is known as underflow condition. For deletion, we will check underflow. For insertion, we will check overflow. Check whether, but why? Because this underflow, we have to see whether elements are there in a queue or not. If elements are not there, you cannot delete an element from the queue. So we are checking this condition underflow. Once this condition becomes false, when the queue is full like this, when the queue is full, the first condition is false. So now you can start deleting an item from the queue. So that is queue of rear. Delete an item, then increment front by 1. This is front by 1. Again repeat the process. Again go back, check this again. Again this condition will fail because front is still here itself. Front is in this second position. Now delete this. Again increment, delete this. Increment, delete this. Increment, delete. Now front is incremented by 1. Now front is what? 5, rear is 4. Okay, now front is greater than rear. That is 5 is greater than rear. When 5 becomes greater than, 5 is greater than 4. When 5 is greater, yes, the condition is true. The meaning is queue is underflow. Queue is empty. You cannot delete any item from the queue. Okay, so that is known as delete operation from queue. This is what a simple snippet we have. Now we have inserted and we have deleted an item. That is, we have inserted. For example, we will take this example. I have not deleted an item. I have inserted certain items to this queue. I need to display these items onto the stack, onto the screen. How to do that? It's a normal display function, whatever we use. That is normal for statement, like what we do in our arrays, just a simple for statement and display all the elements present in a queue. But for that, very important thing, we have to check this condition. Queue is empty. If the queue is empty, you cannot display any elements on the queue. So we will check this condition if front is greater than rear. That is what we did in the deletion operation. If front, for example, front will come here. If front is greater than rear, none of the items will be there in a queue. Okay, so that we have to check the condition. If it is not empty, keep on displaying the items. That is, write a simple for statement for I equals to 0, I less than I plus plus, display first element 10, then second element, then third element, then fourth element. Till you reach this condition, you have to display all the elements. That is known as just a simple display property that we use in our all display program using arrays. Okay, so this is one simple snippet of code I have given over here to insert, delete and display. Look here, this is an insert code. That is whatever we done, rear equals to q minus 1. This is the important condition we have to check for overflow. Then rear equals to rear plus 1 and insert an item. This is what insertion. Then I am writing front, delete at front if front is greater than rear. This is what condition for underflow. Check for underflow. If it is false, that is delete an item from the queue, then increment front by 1. This process repeats until all the items are deleted. Okay, once you have inserted items into the queue you want to display, you can go with this display the elements first, and then you can delete the item. This is how the simple snippet of queues will work. So this is what a simple concept of queues. Thank you.